All right, we are going to get started. So, hi, I'm Jacob. I'm the moderator. I will politely but mercilessly keep us on task. We're very delighted to have David Bau and Sarah Schwettmann hosting this fireside chat. Both, more and less recently coming from the Boston area. David has done a lot of amazing work in interpretability, and actually so has Sarah. But now Sarah is my amazing co-founder, and David is saving the world, I think. He'll tell us more what he's up to. So here's how things will work. We'll kind of have some general context-setting questions at the beginning to just kind of help everyone kind of understand what we're all talking about. It'll probably be like around 20 minutes, and then opening up the floor to audience questions. So we want to make this very interactive and leave lots of time for audience Q&A. So with that, let's get started. I'll start with maybe my spiciest question. This one is for David. So I heard a rumor from my East Coast friends that you've been telling people that you think OpenAI might not be around in 3 years.
Yeah.
And I wonder if you could please elaborate.
Right. It's because I've seen this story before. I'm old enough that I sort of lived through the first internet boom, and I remember the years when people thought that the whole internet game was going to be over when the internet was fully built, and the whole thing was like, can we connect 8 billion people? When everybody's connected is done, and the game will be won by the company that can build the access monopoly. So on the cover of Fortune magazine, who's going to build this monopoly? The companies were in a race, and clearly the winner was AOL, right? You know what the valuation of AOL was? $350 billion. Sound familiar? Right? And where are they today? I'm not sure who owns that Time Warner building in the middle of Manhattan, right? Where are they, right? And so fundamentally, what they were missing was that they misunderstood what it meant to invest in the ecosystem. They didn't invest in an ecosystem. They didn't, create the conditions or invest in solutions for what you might call internet interpretability, right? They thought it was about building an access monopoly, getting the first to be out there. Who ended up winning? Who would you say was like the dominant internet companies today? Wait, who? Yeah, Amazon. Yes, Amazon. Any other dominant internet companies? Google. Yes, Amazon, Google. Maybe Amazon, Google, right? Microsoft did okay, but yeah, I wouldn't blame it on the internet. There's probably Windows still. But Windows is a good example of another ecosystem here. But Google fundamentally solved this wild and woolly problem that the AOL didn't solve, which is what to do about going and communicating with somebody on the internet that you've never met before, that you have no reason to trust. There's this web page, is it good, is it bad? Should you trust this dating service? Just go on a date with this person you found on the internet? Should you buy a product? Can you swipe your credit card here? Right, so Google organized the internet well enough to make it understandable and trustable for people. It's a hard problem. Required them to crawl every page and analyze all sorts of stuff, right? AOL didn't think that they had to solve that hard problem. The internet was mysterious, but if you connected everybody, it's good enough. Just give everybody an email address and charge them access fees. And today, the AI is deeply mysterious, not just to users, but to experts too. But we're like, Doesn't matter, right? Let's just build a monopoly. It'll be enough. We'll charge everybody, some dollars a month for some access. It'll be fine. Somebody will make progress on this problem, and when they do, then people will realize what they're missing, and then OpenAI will wonder, I wonder why we didn't, invest in that, and so that's my prediction. Anyway, so that's just a little context. Yeah.
So. Okay, great. So next question, which I'm also very curious about. I've been strategically kept in the dark about the title of this chat, Why Read the Code? So could you explain, what does Why Read the Code mean? Maybe we can start with Sarah and then go to David.
Sure. So this actually grew out of a phone conversation that David and I had a few weeks ago at this point. And we've known each other a while. David and I actually started our PhDs at the same time, and we're in Boston at MIT doing our PhDs together. And I've moved out here to build Transluce, and David and I were catching up, and we were discussing, what do humans stand to lose maybe in this era of AI, in light of these conversations around transparency and where you have maybe growing giants like OpenAI giving us a little bit of access and allowing us to query these systems. And so we started chatting about this on the phone and came to a realization together that then inspired this event and the title of this event, where we got to thinking that, throughout history, an essentially human activity has been measuring and understanding our environment and kind of the material reality that we reside in. And we kind of model this system and we distill it into useful abstractions like a periodic table of the elements. And we're able to invent things on top of it, like figuring out combustion and steam engines. And we're able to kind of build on top of the world that we live in by understanding how it works and having fast feedback loops between trying something maybe scientifically that engages that physical reality and tests some understanding of how it works by building directly atop it, and then iterating. And that's been kind of a driver underlying scientific and societal and human progress and imagination for as long as we've been around. And that really rests on our fundamental ability to observe and access kind of the reality that we inhabit. I know that sounds like a grandiose claim, but it's true. We can directly measure and observe the world that we live in, and that's been kind of key to science. But increasingly, something pretty interesting is happening where we're interacting and living in a world built kind of on software instead of on this hardware, right, that I can reach out and measure. And the big change that I feel very sensitive to is when we can no longer probe that world that we live in the same way that we've been able to probe physical reality. And that's going to limit a pretty fundamental human activity of measuring, understanding, and building in a way where kind of everybody has essentially access to that world in the same way. Granted, we have different sets of tools, and we're driven to innovate better tools to be able to build better, but that fundamental access is required. And when that world becomes one of software instead of hardware or physical hardware, the question David and I started chewing on was, what happens when we can't read the code, that software underlying an increasingly digital reality that shapes our lives and our societies, our interactions, the health of our information ecosystem, the leaders we elect? All of that boils down in many ways these days to software. And if this becomes governed by code that we don't have access to, maybe we'll lose something about this fundamentally human activity of probing it and building on top of it.
So this has been happening for decades as we've been building a more and more software-driven world in general. But the AI industry has added this crazy extra layer on top of it. It's this second curtain. So there's the ordinary opacity of like really complicated software, and I think this has just been a rising concern. Why does a meme spread on Facebook or Twitter, right? Like why? Like it can cause populations to rise. How does this happen? How do these dynamics happen? Nobody knows what the ranking function is. Nobody knows why it behaves the way it does. So the complexity of software is already a serious problem. But on top of that, we've drawn like these two curtains. There's the ordinary curtain of proprietary, software secrecy that goes behind things. But now there's this other bizarre curtain that we've drawn around our industry, which is we've created this whole field of machine learning, of self-programmed complex systems, and we've resigned ourselves to the idea that they're ineffable black boxes. And so not only do we keep them secret, but even the people inside the corporate structures where they're inside the curtain of secrecy, they don't understand what their own software is doing, right? Nobody understands it. The expert scientists don't understand it. And I kind of feel like, wow, we're really biting off a pretty serious problem for humanity here. I feel like this is, one of the fundamental challenges that we face. Where does human agency come from in a world where we just continue to create surprises and mysteries for ourselves in these opaque systems that we make, and so with the change in the administration, the Trump administration came in and they looked at AI policy. They dismissed all of the stuff. They said, oh, the Biden administration, they don't know what they're doing. So they sort of set that aside, and then they sent out this RFI and they said, what's your advice for what to do about AI? And so, so Sarah and I ended up writing a memo together to the Trump administration. You can find it on the web. That talks about the importance of cracking open some of these transparency questions. Actually, there's two memos to take a look at. So that's what sparked sort of this conversation. Led to Sarah saying, "Oh, you should come to Silicon Valley and hang out and talk with people." Yeah.
And we started publicizing this event, and I got a lot of feedback. So, what do you mean read the code? Do you mean can we, or are we even allowed? And that was an interesting, double-edged sword that David pointed out, right? Do we have access to begin with that we need in order to start building the tools that we'll use to understand the world of AI? And then once we actually have that requisite access, what do we do with it? Can experts really discern these systems? And these are both, I think, questions that we tackle in different ways in the work.
And so I want to get back to these kind of ecosystem questions in a second, but maybe as like one last piece of context setting, David, you recently started this new initiative called NDIF, and I'm wondering if you could tell us more about. I'm told all the cool kids are using NDIF, but
yes, there's this nice library that you might have used called NSIGHT that comes from the NDIF project also. So it's basically it's infrastructure. So it's a different vision for how AI technical infrastructure could be set up. So right now, when you use OpenAI or Anthropic as an engineer, it is set up technically as a black box system, right? You form your inputs, you send it over the wall to the black box, and you just get these outputs back, and you get no insight into what happened in there at all. And I don't know, like if you go to any of these machine learning departments and you walk the hallways and you ask people what are they doing for their PhD, this level of access is really not sufficient for any of, maybe a little bit, but almost none of the deep innovations that are happening. Like this access isn't really empowering. It's not the kind of thing that will allow for interpretability or other types of innovations that are really deep in the AI space. And so what NDIF is, it's a reimagining of what an interface could be if inference really enabled the developers and engineers to really innovate on top of it. So when you use the NDIF inference API, then you get access to activations and gradients, and you can make changes, you can do interventions, you can introduce supplementary models, you can do all sorts of crazy things. You could do most of this sort of dissertation research on top of an inference API like this. And so one of my agendas coming to Silicon Valley is to go to all the grad students and visiting the universities and say, you should use NDiff. This is, it'll help your research. And then coming to companies and saying, hey, maybe you should offer NDiff or participate in or develop an interface that has the technical capabilities that's similar to NDiff. And so NDiff is, it's called the National Deep Inference Fabric. It's because it comes out of an NSF grant for researching, improved interfaces with these sort of research capabilities, and that's what that is.
I think so this brings us back to these kind of questions around transparency in the ecosystem. Sarah, you kind of left MIT to start Transluce. David, you left MIT a little bit earlier and eventually started NDiff. How I guess first of all the question is, in general, what do you think the AI ecosystem needs to kind of address the challenges you've been talking about, and how does your own work fit into this?
Yeah, that's a pretty big question. I can try and give a brief overview of how we're kind of carving up that pie at Transluce, and the work that David's doing around NDiff is a big part of that, or it's piloting what kind of technical access standards might look like as one piece of this puzzle. How does an ecosystem start to learn to understand systems that are pretty complex? So if we break down kind of the pieces of the understanding ecosystem, right now what's happening is that labs and frontier labs that build very advanced state-of-the-art systems develop techniques for understanding and accessing them that are pretty ad hoc. They're developed behind closed doors, and so they all look a little bit different. They have different APIs for accessing a system, and those APIs might expose different things internally. People that run benchmarks and compute metrics on models all return something slightly different, and we don't really have standard ways of accessing information about models or accessing results of an evaluation after it's been run, such that a human investigator or AI system could automatically run hundreds or thousands more experiments on top of that same model that looked like one evaluation was run that produced kind of one top-level metric number. So in order to kind of create reproducible understanding and eventually kind of audit systems like AI models, we need audit standards, and that's kind of a big topic, but we need kind of standard frameworks for what kind of information we want to uncover, what kind of questions we want to ask about systems. Maybe one example question is, does this model ever do anything surprising, right? Or does this model ever say anything that resembles kind of righteous anger toward a user, or human-like anger toward a user? So that would be part of an audit standard. What kinds of things do we actually want to audit for? Okay, once you have an audit standard, you need something that looks like a technical access standard. It's like, all right, now we know what we're looking for. How do we get it? What information actually needs to be exposed about these systems in order for us to answer this question, like, does this model ever do anything surprising, or does it ever display righteous anger toward a user? And one of the things you might need to expose is kind of log probs, right? Different information about a system that you could use in some technical assessment protocol to answer that question. So maybe we need technical standards for accessing frontier models that expose the right kind of information. That's kind of where NDiff fits in. And once you have those, we actually need kind of new technical innovation and real R&D to build tools that allow us to actually answer those questions. So you want to look for surprising behaviors, and you need kind of log probabilities of some AI model that you're investigating, and hopefully companies are exposing this information in a standard enough way that you can solve the problem one time instead of n times. Then we actually need to do some R&D and do something like train an investigator agent that can use those log probs to automatically elicit those behaviors from a model and answer something like, hey, did it ever do anything surprising? Or what are the types of inputs on which it starts to get really angry or do something we wouldn't want it to do toward users in the wild? So those three pieces, like audit standards, access standards, and then technical R&D, are kind of necessary for an independent understanding ecosystem. And here, at least, we're doing a lot of that R&D and trying to contribute to the standards conversation by doing that work in the open so that, we can coordinate across independent efforts to solve that standards problem, kind of all start working on the same reusable toolkit.
Right, I think my perspective, my focus is slightly, maybe narrower than what Sarah looks at, because I'm so focused on the technical access part of the issue. But I think there's a larger thing that I'm concerned about in the way that we approach our industry, which is, there's a lot of technical discussions about how to create AI models that are more robust, right? Which is really about improving the technology to anticipate the different problems that might occur, if you adversarially attack it, or if you push it out of domain and it does something unexpected. Can we anticipate these things and prevent them from happening ahead of time? But but there's a second kind of robustness which we're really not focused on enough in our industry, which I think is actually even more important, which is resilience, which is, look, these are the most complex technical systems humanity has ever created. They are going to go wrong. They are going to misbehave. How do we make sure that the world is set up in a way that things keep on functioning okay anyway? When they do, how do we build resilience? And I think that if all you focus on is robustness, then it's easy to fool yourself as, one of the one of the foundation model companies, one of the frontier companies, to think, oh, we'll just have a bunch of experts in our company work on the robustness problem. We'll make sure our model is robust and make sure it doesn't do anything wrong, right? But resilience is really about the community. It's really about, preparing everybody in society to understand what it is that we're dealing with, what kind of misbehavior we might see, what kinds of things do we know, what do we not know, how do we debug systems, how do you control systems when they act in an unexpected way. And if just a few people have this expertise and know these kinds of things, then the whole ecosystem is very fragile, it's very brittle. And the way to get resilience is to have broad participation and broad knowledge across society with a lot of different diverse innovators in this type of thing. And I feel like as an industry, we're really underinvesting in the human capital that you need to build a really, robust, resilient ecosystem around AI. And this is the thing that, so standards may seem like a weird, technical, dry topic, but it's the thing that enables these ecosystems, and so I think that's why, that's for me, that's the bigger, reason to come and focus on these standards and this kind of thing. It's to build the community.
So you kind of talked about enabling this ecosystem. But it seems like a thing that this relies on is, you could have the standards, but someone needs to actually give you the access. And it seems like this is asking for a pretty high degree of access from companies that have historically given very low degrees of access. And, maybe even for kind of, pretty understandable reasons, like concerns about IP and stuff like that. So I guess, I'm wondering, how you kind of tie this vision in with that kind of, state of the world.
Yeah. Can I answer this one? Sure, so I think there's a couple pieces of the answer here. So I think actually, if you really think about resilience carefully, you realize that, there's this debate about access that is very black and white today, but the reality is that it's not really, that's not the limitation of what we have. People say, oh, do you have closed models, or is it throw open the doors and everything's open source? And there are other distribution models that are between those two things. There are more transparent hosted models. So one of my one of my jihads going on right now is, we've developed this NDIF standard, and it is a third way. It's a different distribution model for hosted services that is far more transparent, that would allow you to really develop different innovations without taking your own copy of the parameters as the distribution model. And so you can manage a hosted distribution the same way that companies manage hosted distributions of existing APIs. There's already concern about, can somebody misuse the API and try to exfiltrate the model or create some misuse. But under a hosted model, you have the ability to audit, you have the ability to bandwidth limit. With the proper API design, you can minimize risks of exfiltration. And so I don't think that, I feel like we've backed ourselves into this weird religious debate about whether open source is the only way to do things or not. But I think that what we should be doing is we should really be thinking about what do we need to do to build a healthy ecosystem, and then be creative and apply some of our technical expertise and our effort to building what we need instead of thinking it's just some binary choice. I think that's my main perspective here.
And I think that kind of the current weirdly religious niche that we're in is a bit of a market failure. I think there's a few things going on. Companies will cite things like, legal liability. This space of liability around model behaviors is pretty underspecified, right? Behaviors might be pretty surprising, and there's significant risk of leaking private data, right? And because that landscape kind of isn't very well understood yet, there's a significant chilling effect on what companies are kind of willing to share. And I think they'll trend toward sharing less, given that the state of liability is still pretty underspecified. And then IP risk too, right? Like you mentioned, actually sharing anything about models exposes companies to some risk of exfiltration and this kind of thing. But I think the biggest maybe issue is the lack of some counter market for understanding, where traditionally companies would incentivize consumers to use their product by sharing information about its quality, right? Oh, I have a really good system. You should use this product because look at all of these rich kind of quality metrics that I can show you about how good it is and all of these different dimensions. And maybe right now what we have in the ecosystem is like tiny metrics that companies will hill climb on, like MMLU or ELOs in Chatbot Arena or something like this. But these don't constitute a kind of rich understanding of a system that we could really use as a public to assess its quality. And in the absence of that, I think companies can kind of grasp at these IP and liability concerns and say, hey, there's reason enough for me not to share this stuff, because there's not really a counter market where sharing it does incentivize creation of higher quality and better models, because that info is out in the open. So I think there's this kind of interplay between building richer tools that give us better understanding of systems and then actually driving some more stable equilibrium where the market will shift us toward like more transparent behaviors.
And I think there's some fear in some of the circles actually pushing us towards openness. There's been the big sort of Wall Street shock about the dynamism and that's emerged in China around DeepSeek and Qwen and DeepSeek R1, and some of that is hype, but I think some of that is genuine. I mean, I think that they've done a good job at assembling and motivating a rock star team of young innovators, and I think that one of the things that they seem to be doing is they are creating a very collaborative, inter-company, academic industry collaborative, open weight ecosystem over there that's really has the potential to accelerate, ground up innovation at a rate that's much faster than what we're building, where if you want to innovate, then you go through the OpenAI job application process, and maybe then even then you don't have access to really what's going on inside the model. I don't know, like anybody here work at OpenAI and don't necessarily have access to the own models that your company is creating, right? And so I think that leadership here is starting to wonder if this is really the wrong model, but it's potentially hard to justify to your venture capital investors who are not that comfortable with handing you the next $100 billion round or whatever, right? For you to turn around and open your parameters for everybody to copy. And so have we gotten ourselves into some sort of trap where we're unable to compete with the open model? I hope not. And I think that it's a good time to be investigating third ways and to focus on the question of can we build the ecosystem that we need? Can we build the dynamism that we need, but do it in a way that's consistent with incentives for intellectual property investment, that's consistent with being able to limit liability and being able to recall models when there's a problem, and do the kinds of things that you'd want to do in a responsible marketplace. Great. And so, yeah.
Okay. Let's open things up for audience questions. Yes.
I was just talking to Jacob about transcripts and the work, and we were talking about providing, I think, tools for explainability to government and regulators, right? I mean, of course, you've seen instances with Meta and what Zuck had to go through in terms of protecting and explaining things to the regulators as well. But I believe a social network would be different from a network of a neural net, and the models have a lot more scope for becoming proprietary in some sense. I was wondering, with providing explainable tools to the regulators, is there scope? I mean, I see it also as a dual risk to reverse engineer and make models adversarial. So where's the trade-off, right? Okay, we need explainability, but if we provide a lot of explainability, there's that increased risk that someone might use it for, adversarial purposes.
Adversarial purposes. I think that I guess there's a technical sort of argument that or discussion that I frequently have about explainability. I think that one of the things to note is that the act of making something explainable to a person, because people really don't consume that many bits, is really a process of digest, is really a process of reducing the information down to make it explainable, understandable to a person. And I think that there's arguments that if you want to really do an adversarial attack easily, if you want to copy a model or you want to do something like this, that fundamentally you need more bits of information, and that explanations are not really the attack vector. I think that if you want to attack a system, then the thing to do is to use ordinary use and to spam it with massive amounts of regular usage and mine all sorts of other things out of, because really what you need is bits. And I don't think that explanations fundamentally change that picture. It's not going to be the best way of getting massive numbers of bits out of the systems to attack them. But it's a technical argument, but maybe in a sense it's also a technical question, right? Yeah.
I think there's another argument too that we can steer systems to behave in ways just by showing them examples of behaviors we want them to emulate. That doesn't require explanation, it just requires mimicry, and AI systems are very good at this. But if we want to be able to prevent and predict those kinds of behaviors, I would argue that the only way to do that well is to actually understand. So through understanding, you might get both the ability to drive, a greater diversity of behaviors, but you also, on the flip side, get the ability to control, right, or to steer the system and predict how it's going to behave in some diversity of scenarios. And I would much prefer a world where those two things kind of grow hand in hand with one another. And if you're going to have increasingly capable systems that can be pointed at things in the world, I would like our ability to understand them, to co-evolve kind of with their strength at being pointed at different tasks, right? So in terms of the dual use question, I think I'm fundamentally okay with a world where systems grow more capable alongside our full ability to control and understand them, rather than kind of a converse world where either one of those things grows disproportionately to the other.
I saw a question back there.
So I see this as there is the need for transparency probably looks different to different kinds of stakeholders, whether it's users, whether it's developers that are building on top of foundational models, developers of foundational models. I could go on, of course. How do you think about the different needs and the different shapes that transparency takes for each of those groups?
Yeah, I think that there's this nice, so a healthy ecosystem has many different levels of participants and different levels of innovators. But I do think that it comes down from the deepest level of access. So if you really want to serve, if you want to really empower end users, if you really want to improve what do they say, the flourishing of humanity and the agency of people, then you are going to need experts technical experts at a variety of disciplines, of subject areas, people who are expert at medical applications, empowering doctors, right? OpenAI is not going to do this on their own, right? So you'll need like an ecosystem of experts who know what it means to empower that radiologist or whoever, but those experts will need to be building on top of other levels of tools, and those tools will build on other levels of tools. And so a healthy ecosystem will have a variety of levels of sort of platform providers, solving the difficult technical problems and making them accessible to the next level of platform providers. Eventually, turns into end user benefits. And I think one of the fears is if you sort of pinch off innovation at the root of the tree, then the whole thing can wither. And so, that's the way I think of it. Yeah.
Yeah, in the back. Yes, you.
Yes. One question I have is I think I'm still struggling to see the types of incentives that we need to form for companies to be more open with their models, even more than just the black box, like between open and black box. I think that, Sarah, I think you were kind of hinting a bit earlier, or suggesting that being more open with, let's say, your activations might mean that you could develop like more expressive forms of evaluations, more than just MMLU to a chocolate arena, that could show your models better. So that could be one type of incentive, but I guess I'm just trying to see, like, from a company's point of view or OpenAI's point of view, because they're already worried about people, distilling their models. I'm just thinking, like, how would they be willing to share activations, for example?
I'll answer more. Yeah, it's great. It's great. So so there's two brief anecdotes here. So one is that somehow there have been companies in the past who've built quite a franchise on a model, even when it's possible to copy the entire product and put it on a thumb drive. I'll sort of note that all shrink-wrap software used to work this way, and Microsoft seems to have a valuable company anyway. I'm not sure how they did it. People can copy Microsoft Windows and it works, right, as a business. But actually, even in AI, there's a positive incentive. So we've been talking about a lot of the negative risks of, like, if you're more open, like maybe these negative things are not as bad as you might imagine, like what investors are worried about. But the upside is actually huge, and we're already seeing that. So for example, I think a lot of us probably like are obsessed by LLMs and this stuff. But so I'm a multimodal person, and I do a lot of my work on the generative image side. And I have to say, like when Stable Diffusion came out, and there were some negative things about them opening the parameters of models from the point of view of misuse and safety. But one of the things that it did do is it sparked this tremendous level of innovation in the generative image field that because you've got this superhuman set of image generators that are now unlocking custom diffusion, Dream Booth, sliders, and all of these other things. So there's this beautiful visualization of Hugging Face that came out a couple weeks ago. I just Google for like the Hugging Face visualization, and you can see that around the different LLMs on Hugging Face, there's like different derivative models that sort of exist and so on. But Stable Diffusion, which really was a superhuman model for image generation, completely open. Around Stable Diffusion and Flux, what are these image models? There's this massive, each one looks like this huge explosion of innovation, thousands of derivative products and all sorts of things. And Adobe is trying to roll a bunch of these innovations that came from this open source world into their products already. They're giving the artists additional artistic control. There's money to be made, doing this stuff. There's upsides for unlocking the secrets of nobody knew that these models could do these things. No, like Stable Diffusion didn't know that with 5 training images, you could add your pet to Stable Diffusion, and you can like have pictures of your pet. That's pretty neat. Nobody knew that you could like control the pose. Nobody knew that you could make a slider for somebody's age or how well cooked the food is or whatever, right? And people didn't know that you could do these things because that's not what scientists at Adobe would have investigated. That's not what scientists at Stable Diffusion would have done. It took like the ecosystem to discover these things, and the ecosystem was enabled there because of the level of openness. So I think that there's this huge upside that we just haven't realized on the large language model foundation model side because we've been stifling it.
And I appreciate talking to David about these things because I'll be like, you can come up with a gray box API that'll really make things safe. Or what about a secure enclave? Or there's all these tools we can use to like really protect IP, and that's what technical access standards are for, so everything can be safe. I say this to David, and like, what if you just incrementally show that with a little more access, we can get a little bit more understanding? And David's like, no, just the upside's so big, just open it all up. All at once, everybody wants to build on top of this stuff. It's not gradual, just like, give them the whole thing. And I'm like, well, I'm never gonna get activations. I mean, I live in SF now, and they're not gonna give you activations. But I do think, so one of the things we do here is think about mechanisms and incentive structures to shift kind of our current equilibrium toward a better one. And I think there are a lot of like creative policy levers that we can pull that don't look like traditional regulation, but look like, okay, maybe you could grant companies something like safe harbor from negligence if they undergo some kind of third-party auditing system, right? And their model is certified as being safe along some standards of care, and then that kind of under tort law, it removes them from legal liability if something then happens, right? And that's what like certification ecosystems will do. So there are mechanisms for kind of incentivizing this sort of thing that could shift equilibriums around these liability questions towards something that also benefits, I think, consumers and the information that they have access to about systems. And I did mention earlier, like, okay, once you make that information more transparent, then people can decide, more what kinds of models they want to use. And I think you don't have to start with activations, right? So I'll give the counter argument to what David said, and like, you don't have to start with that. Even like behavior can tell you so much, right? You can mine behavior traces. And these are kinds of things that companies that are worried about keeping activations under lock and key could give to third-party auditors in some kind of trusted ecosystem that looks like, one where companies can receive safe harbor from negligence for providing this information. And if you give third-party auditors access, like secure access to this kind of information, then it's the role and job of those independent third parties to convey quality information to the broader public. And that's different from, hey, broader public, you can hook into the model and steer it and create, sliders for your pet. It's like, oh, there are trusted bodies that provide this kind of evidence of system quality to the rest of consumers so they can make more informed decisions about products that they want to buy and that they want to use. And then if a company opts out of sharing that kind of quality information about their model, they look very bad, right? Oh, why aren't you sharing how good your model is along these dimensions that everybody is using, right? And in the absence of that, you can end up with something that looks more like a market for limits, where everybody keeps quality information under wraps. And so you really want to shift things more toward a world where companies are incentivized to share not IP about architecture, but information about model quality. And then I think once you're there, it's pretty stable. And that's what we're, I think, trying to shift toward.
Yes.
Maybe there is no question or something even by ignorance. I'm just curious that transparency is very important, but there's a very limited way of studying the transparency, but the behavior or trust is a bit easier to evaluate. And a lot of this new system comes that they show the performance measure, like we can do this number, this number, this number. But is there some kind of measure that we can see that it's actually answering the questions to see that there is any contradictions? Is it really honest? That is there some kind of measure to see that they are really a bit trustable?
Do you want to talk about faithfulness to explanations, or I want you to talk about it?
Well, I want to talk about what we're building here. And
you can talk about it. Yeah, sure.
Faithfulness to
Sure. Okay. Yeah, sure. Yeah. So I'll talk a little bit about that, but that's certainly what I think that's one of the central questions, because with these language models, you can certainly ask them to explain themselves, and there's certainly a lot of users out there who are like, oh yeah, that's what it says. That's an explanation. Okay, I got it. And I kind of feel like it's like going on to the original internet and saying, oh yeah, they looks like they have a nice vacation home in Florida to rent me. I sent them my credit card number. It sounds pretty good. And then you show up and there's like, that street isn't on the map. Where is this place, right? Was that hallucinated, or was that on purpose, right? I think that so we have this issue here, and so we call that the faithfulness gap, where even when it looks like the models are trying to be helpful and explaining things to you, we don't know whether it's kind of quote intentional or not, without like a deeper understanding of models, but they frequently will lie to us by accident or not, and I think that navigating this is part of that dark matter of AI, right? It's the thing that was analogous to the problem that AOL never solved on the internet. Right, that we are underestimating the challenges of dealing with this in AI today. We think, oh, it's so useful, right? But actually, there's this core barrier. I mean, we talk about abstractions. There's this core barrier to human agency. Like, can you actually do what you want, right? Because you don't know what the model is actually trying to do. Is it actually fundamentally telling me the truth? Is it actually trying to help me? Right, we don't know, and as the models get more and more sophisticated and work on more complicated things, this will be harder and harder for us to discern. And so, I think this is the big unsolved problem. And okay, so you can talk about how translucent is helping us.
David sets me up so nicely. I think the other problem is that these metrics that we use also lie to us, right? These numbers don't tell the full story, and we'll see, a model got 74% on some common benchmark, and we're supposed to trust that means it's either safe to deploy or it's above some threshold. But on the outside and also on the inside, we don't actually know what that means. And there could be a lot of different things going on under the hood that result in some top-level number that's supposed to capture something about a system's performance. What we really want to know is like why it failed to solve tasks that it was unable to solve, or maybe on tasks that it was able to solve, did it memorize the answer, right? Like what was actually going on there? And for tasks that it couldn't solve, like how far was a system actually from goal, right? Like would some simple intervention, like giving an AI system or an agent access to the internet, give it the ability to solve the problem, right? Or would you need to intervene and do something a little more complex to get it all the way to goal, like step by step, give it the correct answer, right? Or a little piece of the puzzle. And those are kind of two very different worlds, right? I might want to know if my system just had access to a couple of tools, or if a human came in and gave it a little hint, it could just do the task. It could break through some firewall, or it could, solve some cyber offense task. Or actually, was it really far away? And right now, our metrics for understanding and communicating about AI systems and their performance don't capture any of this richer context and information. And we really want some information that's kind of like counterfactual, right? Inherently counterfactual, where you know what would happen if you perturbed something really small about the environment where an agent was acting, right? Or you gave it these kinds of hints. So that's one of the things we're working on here. We're building something called Docent. That allows both humans and AI investigators to kind of run these counterfactual experiments and intervene on aspects of an agent's environment, and also summarize kind of what's going on under the hood of common benchmarks that we all use to understand performance. And you find kind of crazy things like, a model's trying to solve some capture the flag task and it just regurgitates the correct flag, right? Or you find surprising behaviors where maybe a benchmark reveals that, it prints out a file path and reveals that the model is actually in a benchmark setting. And all of a sudden, it no longer wants to do the task anymore because it knows it's being evaluated, right? And this is the kind of stuff that we don't see in those numbers. So we're pretty excited about tools that let everybody kind of distill this richer information and do something interesting with it.
Yes?
It feels like there's all different kinds of transparency, targeted towards different groups. There, like activations that would be useful to the research community to do things like what you said with Stable Diffusion, and these kinds of rich sort of behavioral evals are maybe important for accreditation or auditing that the model is say fit for X or Y purpose. But I'm curious about the transparency to the end user. As you said, understandability is kind of about reducing the number of bits, as much as possible, so that someone can understand what your explanation is saying. And someone talking to a model isn't going to be interested in the activations. They're they want to know what to do with them or have the hardware to do anything with them. I'm curious, what bits would you want to see provided to an end user talking to a chatbot? That would be the most informative.
Yeah, I think that, if I had the perfect answer for that, then maybe I should be down on Sand Hill Road, raising funds for my next startup. My real argument is that there's a lot of genius out there, and we need to unlock that innovation. That eventually it'll lead to more resilience in the ecosystem and more, better, safer products for people. But I'll give you an example. So I think that when my students work on the Stable Diffusion stuff, they have access to the activations, and they do all this very technical work at developing, figuring out how to navigate the latent spaces and train, low rank, parameter efficient, changes in models to achieve different effects and to automatically figure out spaces. But in the end, it really turns into simple things that end user artists would want to use. Like when so Adobe is trying to put these things into products where a user will do the classical Mid-Journey thing. They'll say, give me a picture of a toy I want a stuffed bear or something, and then what these technical tools will provide is that by looking inside the models, we won't tell the user, oh, neuron 79 is firing. You should you should pay attention to that one. No, it turns into a little thing saying, oh, do you mean you want a plush bear or a knitted bear? Or maybe you'd like a Lego bear, right? There's different ways of making a toy bear, right? Or maybe a robot one. And what these things are doing is they go into the model and they say, oh, look, the model's thinking about these things, it's making these internal decisions about which way to do one thing or the other, but with the normal interface, it's not exposing these decisions to the user, but through whatever analysis the technical experts are doing, we're realizing that there's these extra pieces of potential, some of them good, some of them bad. Maybe there's ways of technically sorting between these, and then you can expose them as simple things that regular users can understand and select and pick and have a little bit more agency, and it makes the products more valuable. It potentially makes the whole ecosystem more robust, gives people more control. And so I don't think that. So we're at this stage where it's all new science, and it feels like, oh, is everybody going to need to know how to use protein folding? But maybe in the end, it's about there's going to be somebody who solves that, and then there's going to be some end product which doesn't look like you have to solve protein folding or whatever to use.
We've kind of come full circle to the original kind of impetus for this conversation around, hey, what are useful abstractions on top of a world such that we can intervene on it and steer it, right, and create on top of it. And I think the science of transparency is figuring out what those abstractions are such that you have kind of a heads-up display on the model you're interacting with or the world that you're engaging with, and then it's distilled into some useful enough slider or abstraction that I, as a user, learn something about the other or the world that I'm engaging with and can, steer it to create more in the way that I'm interested in, right? But we need that kind of raw access to begin with to come up with those abstractions and figure out kind of what those sliders should be.
All right, we have time for one last question. Yes.
I think maybe to summarize in terms of the whole conversation, maybe could you guys give us some key takeaways, going below the system level as individuals? What can we do, broad strokes? What can we do to contribute to the conversation of transparency? And how can we bring that up? I mean, of course, the narratives usually are always dominated in absolutes, right? Open source or closed source. There's no middle ground that usually people find. And I think David also talked about it. So what would be the middle ground to start the conversation?
So I don't know how many students we have in the audience, but there's a message that I'm delivering to students all the time, which is, we're building NDIF. We're building a third way of accessing models, and instead of waiting around trying to figure out how to get access to a GPU to run your thing, check out the NDIF website. Maybe it has the technical facility you want. Maybe you want to run your next experiment on it. And if people if you use it and it doesn't work for you, then let us know, because the goal is to actually make these systems, make this third way of using systems actually useful and usable. And the more people engage in it and use it, the more then we can kind of get away from this black and white, all open, all closed kind of thing, and really focus on what we need to do in a practical way to build the ecosystem. So I'd say run your experiments on NDIF. Yeah.
Or run any experiments at all that teach us what we can learn from varying degrees of access, right? And I think the more kind of proofs of concept we have of, with this kind of access, you can achieve this kind of understanding. We need public demonstrations of that to be able to push for kind of greater amounts of transparency and to indicate like why it's necessary and useful. We want to do this because it's useful, not for some dogmatic reason, but because we truly believe that, you know, with transparent access, we'll be able to understand and build kind of beautiful things. So doing that work in public, I think, is the best way to drive the conversation toward transparency that will enable more people to be able to do that to begin with.
Yeah.
All right, on that inspiring note, let's thank our speakers.